Now we will continue with the other topic, that is pressure exerted by gases. So here we have to do the pressure exert, the air exert pressure because gas exerts pressures, and then some examples of applications of this pressure of air column in our daily life. So what is atmospheric pressure? So first one is atmospheric pressure. It is on page number 46. Okay. Atmosphere causes a thrust of 1 lakh Newton on every 1 meter square surface on the surface area on the earth. So we know that the earth is surrounded by air column called atmosphere. This atmosphere exerts a kind of pressure or thrust on the surface of the earth. How much? 1 lakh Newton on 1 meter square surface of the earth. That is atmospheric pressure. The pressure exerted by the atmosphere on the surface of the earth is called the atmospheric pressure. And how much it is there? 1 lakh Newton on 1 meter square surface area of the earth. And the next one is measurement of pressure. Pressure is measured using an instrument called a manometer. And then what is the structure of this manometer? It consists of a glass U-tube containing mercury mounted against a scale on a vertical board. You have seen this BP apparatus, that is sphygmomanometer. It is like this. Inverted U-tube mounted on a scale. It is kept on a scale, and mercury. It is inserted with the mercury. This is an inverted U-tube mounted on a scale, and this U-tube has mercury in it. And one end of the tube is open. The other end is connected to a rubber tube. This tube is connected to a thistle funnel with a rubber membrane stretched across its wider mouth. So one end is open, this U-tube's one end is open, and the other end is connected with a rubber tube, and this rubber tube is connected to a thistle funnel, and thistle funnel's open end is closed with a stretched membrane, with the rubber membrane stretched wider mouth. So now normally the level of the liquid in two arms of the U-tube is same. You see, actually the pressure should be the same now, but here you see one side it is 80, the other side it is 60, because if the membrane is pressed, the result changes in the level of liquid of the two arms of the U-tube. So when here we exert some pressure on this one, so what happens? When we press here, the level rises down, and this side it increases. It rises up. Actually it was supposed to be 80-80 or 60-60. It was supposed to be 60-60 or 70-70. Let's suppose it was supposed to be 70-70, but when it is connected like this and this membrane is pressed, what happens? Gas enters through this and it pushes the mercury from this side down. So from 70 it lowered into 60, and here what happens? From 70 it rises to 80. So rise in the level. 60, this much it has risen. If the membrane press, it results in change in the level of the liquid in two arms of the U-tube. The difference in the level gives the pressure. This can be shown in the help of a following activity. So many activities are shown here. And next one is pressure of gases. Like solids and liquids, gas also exert pressure. If we keep on blowing air in the balloon, it bursts due to increase in pressure. Why a balloon bursts? When we overinflate it, because of the pressure of the air column, because the balloon's membrane or balloon's material could not withstand the pressure of the air column. So next one is air is a mixture of gases. But we know our earth is surrounded by bands of air called the atmosphere of the earth. In other words, we can say that our atmosphere causes pressure on earth called the atmospheric pressure. Now some activities. First one, to show that air exerts pressure. What are the materials required? Materials required are a glass, a cardboard and water. Only three materials are required. First one is a glass, simple plain glass, and then a cardboard, so plain glass where with which you drink water and all, and then a cardboard and water. So now fill the glass with water up to its brim. So you have to fill the glass till its brim and place the cardboard on top of it. Then press the board with one hand on top. So you have to this way. You have to fill it, place the cardboard on it and press it with your hand. Invert the glass gently filled with water. So you have to keep it upside down. Gently remove your hand from the cardboard. So if you remove the cardboard, what will happen? Nothing will happen. Cardboard will not fall in spite of the pressure due to water in the glass. Why? Because the air column below is exerting pressure on. So though we say liquid exerts pressure downwards and the air column atmospheric pressure exerts pressure upwards. So it balances. The pressure on the cardboard due to water in the glass gets balanced by the atmospheric pressure acting upwards. So this cardboard will not fall. So let's now perform an activity to prove that atmospheric pressure exerts force on objects on the surface of the earth. So now force due to atmospheric pressure. A tin, what are the materials required? You see, a tin can having thin walls, airtight lid. It has an airtight lid also. Water, burner, bucket having cold water, bottle full of cold water. So many things are required. Wire gauge and stand. So what are the things? A lid, tin can, and then water, then wire gauge, burner, then water full of a bucket full of water and a cold water, bottle full of cold water. So now what we are doing, fill some water in the can. So we have to put the water in the tin can and then heat the can till water boils. Water boils and the steam starts coming up. Steam is coming through this lid. Then what they did, they replaced the lid of the tin and remove it from the burner and then placed it in the bucket and poured cold water on it. So what happens? Obviously the can will be collapses means it changes its shape. Why? When cold water is poured, steam condenses into water, leaving some vacuum in the can. The air pressure from outside is now more than that of the pressure inside the can. So air pressure outside is more than the pressure inside the can. So this exerts air pressure from outside, exerts force on the can due to which can get deformed. So it gets, so what the pressure inside this will be less and from all the side pressure is exerted on it. So what happens? It gets deformed. Another form is normal. You might have seen also. It's normal that when we have, just as you see what we have done, we have placed we have kept water in it and boiled it. After boiling, we removed it from the burner and kept the lid and placed in the water. When it was burning, it has steam inside, air column inside, air inside here also, outside also. It was balancing. But when water is poured, what happens? The steam condenses into water again, and the equilibrium between the pressure inside and this one gets changed. Now pressure from outside is more, so the box or the bottle gets deformed, tilt हो जाता है. Okay.